managing and monitoring elastic cloud applications using the c-Eclipse and JCatascopia open source tools. Application deployment, management and monitoring in the cloud infrastructure as a service model can be a complex and time-consuming endeavor. To minimize this effort, two powerful open source tools are introduced: c-Eclipse, a cloud application management framework for describing cloud applications along with their elasticity requirements, and JCatascopia, a fully automated, multi-layer, interoperable cloud monitoring system. This work was conducted in the context of the SILR project with partial support from the European Commission. In this video we showcase the use of the c-Eclipse tool for describing and deploying cloud applications and JCatascopia for monitoring the performance of the deployments. First, using c-Eclipse, the user creates a vendor-neutral description of the application containing its topology, together with the artifacts required to realize its deployment. Such artifacts can be the application executables and binary artifacts, the deployment scripts and the key pairs for accessing the deployment. The important metrics to be monitored by the JCatascopia monitoring system can also be specified. In the next phase, the application submission phase, the user selects Amazon as the cloud vendor for deploying the application, and he enriches the vendor-neutral description with Amazon-specific information, such as virtual machine images and elasticity strategies. Then, the application's description is sent for deployment to the orchestrator hosted on Amazon EC2, and the deployment status is presented in c-Eclipse. Once the application is up and running, JCatascopia collects the specified low-level and application-level performance metrics and displays them to the user through intuitive graphs. Users can also create at runtime aggregated monitoring metrics, which are also presented graphically through the JCatascopia web interface. Finally, the deployment scales at runtime by adding and removing virtual machines, based on the elasticity strategies specified by the user in c-Eclipse, and the monitoring metrics reported by JCatascopia. JCatascopia monitoring agents are added and removed automatically to satisfy the new deployment resulted by the scaling actions. c-Eclipse can be used for describing simple applications such as a two-tier WordPress application, and more complex applications such as online gaming. The first step when describing applications in c-Eclipse is the creation of a new cloud project. Here we are gonna describe a three-tier video streaming application. The cloud project structure is automatically created. The application files can be imported to the Applications folder. The deployment reconfiguration scripts, the key pairs and the virtual machine images can also be imported to the project. The next step is the creation of a new application description file for the video streaming application. The palette is automatically generated including user files imported in the cloud project. Following is the description of a three-tier video streaming application. The application files and the deployment artifacts are specified. An example of a deployment artifact can be a bash script for configuring a Cassandra node. The key pairs specification can be used to manually access the deployed virtual machine. The application topology consists of the load balancer, the application server, the Cassandra seed and the Cassandra node. The application description can be customized for a specific cloud provider. We first select Amazon Elastic Cloud. Amazon EC2 specific information are now added to the palette. These information includes Amazon virtual machine images, Amazon's CloudWatch monitoring metrics, and scaling actions supported by the underlying platform. For each application component we specify deployment details such as, the virtual machine image, the minimum and maximum number of instances, and the desired metrics to be monitored. For the Cassandra node, we select total memory. For the Cassandra cluster, we select total CPU. The Monitoring Metrics section presents the selected metrics. What remains is to specify the elasticity strategies for the deployment. First, we specify the elasticity strategy for the whole application. The strategy is to minimize the cost. Then, we specify elasticity strategies for each component. For the application server, we want the number of connections to be less than 40. For the Cassandra cluster, we want to add a new VM when the CPU usage exceeds 80%. The graphical application description is translated on the fly into TOSCA XML. Finally, we can select a provider to deploy our Elastic application. Here, we select Amazon. In order to monitor our deployment, we use the JCatascopia monitoring system. JCatascopia automatically detects new instances. There is no need to restart or to reconfigure the monitoring process after a new instance is available. The AWS console is waiting for initial instances to be deployed. The 3-tier online video streaming service is deployed. The deployment consists of a load balancer, a Tomcat application server, and 2 Cassandra NoSQL database nodes. The deployment view of c-Eclipse presents the status of the deployments. With JCatascopia, we can create a new subscription to calculate the CPU utilization for the Cassandra database backend. Here, we create another metric subscription to calculate the average number of active connections on the application server tier. As shown in the Tomcat connections graph, an increasing workload is imposed to the deployment. When the average number of connections gets too high, the application tier will automatically be scaled. The scaling process results to the deployment and configuration of a new application server. The newly created server is automatically detected by JCatascopia. At the same time, the aggregation rule is automatically updated with a new instance. When the average CPU load imposed to the Cassandra backend is rising, a new Cassandra node and an application server are added. The deployment is now comprised of 7 instances. Adding a new application server initially helps, but the workload is still too large. So another application server must be added. The deployment is now comprised of 8 instances. The deployment continues to scale and it is now comprised of 10 instances. After a while, Cassandra scales from 4 to 6 nodes. When the workload is dropping, an instance is automatically removed. The JCatascopia automatically detects that an instance has been removed. Now the workload is rising again. The final deployment will be comprised of 13 instances. 1 load balancer, 5 application servers, and 7 Cassandra nodes. Here, we can see the HAProxy Load Balancer available metrics. Users can view the number of application servers assigned to a load balancer. We can see the Cassandra node available metrics. Tomcat application server available metrics. Finally, users can view a number of Tomcat-specific metrics, such as the number of active connections,